Imagine driving down a highway at 70 miles per hour. Beneath your tires lies a surface so ordinary that most people never think about it. But here's what nobody tells you. That black road beneath you was born from crushed mountains, liquid stone, scorching heat, and one of the largest industrial supply chains on Earth. Every year, billions of tons of asphalt connect cities, countries, and entire economies. Yet very few people have ever seen how it's actually made. Think about this. Asphalt covers more than 90% of paved roads in the United States alone. It withstands blazing summer heat, freezing winter temperatures, heavy trucks weighing up to 80,000 pounds, and millions of tire impacts every single day. Yet despite this punishment, a well-made asphalt road can survive for decades. The secret lies in a manufacturing process that begins long before the first truck reaches a paving site. Today, we're going inside the hidden world of asphalt production. You'll follow raw materials from giant quarries and oil refineries to roaring asphalt plants where temperatures climb above 300 degrees Fahrenheit. You'll see machines that can produce hundreds of tons every hour, and you'll discover why a tiny change in temperature can mean the difference between a perfect road and a costly failure. And what happens at the heart of the plant surprised even experienced engineers. Everything starts with stone. Most asphalt mixtures contain about 93 to 95% aggregate by weight. That aggregate comes from enormous quarries where workers blast and crush granite, limestone, basalt, or gravel into precisely sized pieces. In countries like the United States, Canada, Germany, China, and Australia, some quarries move tens of thousands of tons of rock every single day. The journey of a road begins with a mountain slowly disappearing. After blasting, rocks enter powerful jaw crushers that can chew through boulders larger than a family car. Steel jaws slam shut with tremendous force, producing a thunderous sound that echoes across the quarry. The material then passes through secondary crushers and vibrating screens until every stone falls within strict size specifications. Some aggregates measure less than a millimeter, while others approach an inch across. Every size serves a specific purpose inside the final mix. But stone alone cannot create asphalt. The ingredient that binds everything together comes from crude oil. During petroleum refining, operators heat crude oil inside distillation towers. Lighter products like gasoline, diesel, and jet fuel rise toward the top. What remains near the bottom is a heavy, sticky substance called bitumen. This dark material becomes the glue that holds entire highways together. Most people never realize that bitumen represents only about 5% of a typical asphalt mixture. Yet that small percentage determines flexibility, durability, and resistance to weather. A single ton of paving-grade bitumen can cost hundreds of dollars depending on oil prices and regional demand. Engineers carefully select different grades depending on climate. Asphalt used in scorching desert regions behaves very differently from asphalt designed for snowy northern highways. The supply chain behind asphalt stretches across continents. Aggregates may travel 50 to 100 miles from quarries to production plants. Bitumen can travel hundreds or even thousands of miles through pipelines, railcars, tanker trucks, and cargo ships. Every delay increases costs. Every temperature change affects handling. Coordinating these movements requires a logistics network that operates almost like a military campaign. And then there's the environmental challenge. Quarry operations consume significant energy. Refining crude oil generates emissions. Asphalt plants require intense heat. To reduce environmental impact, manufacturers increasingly use recycled asphalt pavement, known as RAP. In some projects, recycled material can make up more than 40% of the final mix. Old roads literally become new roads, reducing waste while saving millions of dollars. By this point, the ingredients are ready. Millions of carefully graded stones wait beside towering silos. Heated bitumen sits inside insulated storage tanks. Everything appears calm. But in the next stage, these simple materials will enter a roaring industrial system where temperatures soar, conveyors race, burners roar like jet engines, and hundreds of tons of asphalt emerge every hour. And this is where it gets truly extraordinary. The moment production begins, the entire plant comes alive. Massive front-end loaders rush back and forth, scooping aggregate from towering stockpiles and feeding it into cold feed bins. Each bin contains a different stone size, and computerized controls regulate exactly how much material enters the system. What looks like a simple pile of rock is actually the beginning of a recipe measured with astonishing precision. A small mistake here can affect thousands of tons of finished asphalt. From the bins, conveyor belts carry the aggregate toward one of the most important machines in the entire facility, the rotary dryer. This giant steel drum can stretch more than 30 feet long and rotate at roughly 4 to 8 revolutions per minute. Inside, a powerful burner blasts temperatures approaching 1,800 to 2,500 degrees Fahrenheit. The roar sounds like a jet engine preparing for takeoff. The heat is intense enough to drive moisture from the stone in just a few minutes. As the stone tumbles through the dryer, its temperature climbs to approximately 300 to 350 degrees Fahrenheit, or about 150 to 177 degrees Celsius. Flights welded inside the drum continuously lift and shower the aggregate through streams of hot air. Moisture evaporates into clouds of steam. You can hear the constant rumble of stone against steel and smell the dusty, mineral scent released by freshly heated rock. Every second matters because uneven heating can weaken the final product. Next comes separation and grading. Vibrating screens sort the heated aggregate into precise size categories. Larger stones move one direction while smaller particles move another. Sensors constantly monitor flow rates and material distribution. Some plants process more than 400 tons of aggregate every hour. Imagine sorting the weight of several fully loaded passenger jets every single shift. Now comes the ingredient that transforms heated stone into asphalt. Bitumen stored inside insulated tanks remains heated between 300 and 340 degrees Fahrenheit, roughly 149 to 171 degrees Celsius. Powerful pumps force the thick black liquid through heated pipes and into the mixing chamber. At this temperature, bitumen flows like heavy syrup. Cool it too much and it becomes difficult to handle. Heat it too much and its properties begin to degrade. Inside the mixer, the transformation happens fast. Heated aggregate and bitumen combine under carefully controlled conditions. In batch plants, mixing may last 30 to 45 seconds. In drum plants, the process occurs continuously as material flows through the system. Mixing temperatures typically remain around 275 to 325 degrees Fahrenheit. During this stage, every stone becomes coated with a thin film of bitumen, creating a flexible yet incredibly durable composite material. What happens next surprised even experienced engineers. The chemical reaction is not a dramatic explosion or visible transformation. Instead, it is all about adhesion. Bitumen wraps around each particle and creates microscopic bonds that allow the material to flex under traffic without falling apart. The final mixture emerges looking deceptively simple, but every ton contains millions of engineered contact points working together to support vehicles for years. Before the asphalt leaves the plant, operators perform constant checks. Temperature sensors verify the mix remains within specification. Modern systems can measure material flow, burner performance, moisture content, and production rates in real time. Some facilities produce between 200 and 600 tons every hour. That's enough asphalt to pave significant stretches of roadway in a single day. Finally, the finished asphalt drops into insulated storage silos or directly into waiting trucks. Fresh mix pours like a black river, releasing waves of heat into the air. The smell is unmistakable. The sound of thousands of stones shifting inside the mixture echoes through the plant. Within minutes, trucks begin racing toward construction sites where the material must be placed before it cools. But here's the mystery. How do manufacturers ensure that every truckload performs exactly the same, whether it's paving a city street, an airport runway, or a highway carrying millions of vehicles? The answer involves laser scanners, intelligent sensors, automated systems, and quality tests so demanding that even tiny defects can trigger rejection. And this is where the science becomes even more impressive. The modern asphalt plant looks nothing like the facilities of 50 years ago. Today, thousands of sensors monitor temperatures, material flow rates, burner efficiency, and moisture levels every second. Computerized control systems analyze this data in real time and make adjustments faster than any human operator could react. Most people never think about this, but every smooth highway begins with millions of digital decisions happening behind the scenes. One of the most important technologies is automated weighing. Load cells beneath aggregate bins can detect tiny changes in weight with remarkable accuracy. Every ingredient enters the mix according to a precisely calculated formula. Some systems achieve measurement tolerances within fractions of a percent. When a plant produces hundreds of tons every hour, that level of precision becomes absolutely critical. Laser scanners now inspect stockpiles, monitor conveyor movement, and calculate material volumes with extraordinary speed. Instead of relying solely on visual estimates, operators receive detailed three-dimensional maps of inventory levels. What once required hours of manual measurement now takes only seconds. The result is greater efficiency, lower waste, and more consistent production. And this is where artificial intelligence enters the story. Modern plants increasingly use AI-driven software to predict equipment failures before they happen. Algorithms analyze vibration patterns, fuel consumption, temperature fluctuations, and production data. If a bearing begins wearing out or a burner starts operating inefficiently, the system can alert operators long before a costly shutdown occurs. What happens next can save companies hundreds of thousands of dollars. But producing asphalt is only half the battle. Every batch must pass a series of quality control tests before engineers trust it beneath thousands of vehicles. Samples travel to laboratories where technicians measure binder content, aggregate distribution, density, air voids, and moisture resistance. Even a small deviation can affect long-term performance. Roads may look simple, but their construction depends on relentless testing. One common test involves compacting asphalt into cylindrical specimens and placing them under extreme pressure. Hydraulic machines simulate years of traffic in a matter of hours. Engineers study how the material deforms, cracks, and recovers under stress. Some testing equipment applies thousands of pounds of force repeatedly, pushing the asphalt to its limits. The goal is simple: discover weaknesses before drivers ever encounter them. Temperature testing proves equally important. Asphalt experiences conditions ranging from freezing winters below -20 degrees Fahrenheit to scorching summer pavement temperatures exceeding 140 degrees Fahrenheit. Laboratories expose samples to extreme environments and monitor their behavior. What sounds like a simple road surface must survive conditions that challenge even advanced engineering materials. International standards help guarantee consistency. Organizations establish strict specifications covering material composition, performance requirements, and production procedures. Rejection rates may remain below a few percent in well-run facilities. Yet even that small percentage represents significant volumes of material. If a batch falls outside tolerance limits, operators may reprocess it or remove it entirely from production. Yet despite all this technology, there remains one moment where human skill often beats machines. Experienced technicians can sometimes identify a problem simply by looking at the mix, listening to equipment, or noticing a subtle change in texture. Decades of hands-on experience create instincts that even advanced software struggles to match. The best plants combine digital precision with human judgment. By now, every truck leaving the plant carries material that has been measured, scanned, tested, analyzed, and approved. But here's the astonishing part. This entire industry operates on a scale so massive that the numbers become difficult to imagine. Billions of tons move across the planet every year. Entire mountains become highways. And the global story of asphalt is even bigger than the factories that produce it. Now zoom out and look at the world from above. Every year, the planet produces roughly 1.6 to 1.8 billion tons of asphalt mixture. That is enough material to build roads that could circle the Earth multiple times. Most people never realize it, but you are surrounded by one of the largest manufactured products on Earth every single day. The global asphalt industry is worth more than $300 billion annually. It supports entire economies through construction, transport, and maintenance. The United States, China, India, Russia, and Germany are among the largest producers, together accounting for a massive share of global output. But here's what makes it even more powerful. This industry never stops. Roads wear out every day, so production must continue around the clock. Millions of workers are involved in this ecosystem worldwide. From quarry operators and refinery engineers to plant technicians and road construction crews, Asphalt supports one of the largest labor networks in modern industry. And yet most of these workers never see the final roads they help create in the bigger picture. Their work disappears beneath tires, traffic, and time. Over the last 50 years, asphalt technology has changed dramatically. In the 1970s, many plants relied on manual controls and basic heating systems. Today, automation, recycling technologies, and performance-modified binders dominate the industry. Modern asphalt can include polymers, rubber from recycled tires, and advanced additives that increase lifespan and flexibility far beyond what was possible decades ago. Here are 3 things most people never think about. First, some highways are designed to last more than 30 years, but only if maintenance is done perfectly. Second, recycled asphalt pavement can reduce construction costs by up to 30% while cutting environmental impact dramatically. And third, the smoothness of a road is measured so precisely that deviations smaller than a few millimeters can determine whether a contractor gets paid in full. Looking ahead, the future of asphalt is even more surprising. Researchers are developing self-healing asphalt that can repair its own cracks using embedded materials activated by heat or sunlight. Smart roads with sensors may soon monitor traffic, weather, and structural integrity in real time. What once was just a simple black surface may soon become an intelligent, living infrastructure network. So the next time you drive down a road, you will never see it the same way again. What feels like a simple surface is actually the result of mountains being crushed, oil being refined, machines roaring at extreme temperatures, and engineers controlling precision at a microscopic level. Every mile of road carries a hidden story of power, heat, and human intelligence working together. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.